Hello students, today we are going to solve some numerical problems from gravitation chapter of class 9th. Okay, so this is our first question. An electron of mass 9.1 into 10 to the power minus 31 kg is at a distance of 10 angstrom from a proton of mass 1.67 into 10 to the power minus 27 kg. Calculate the gravitational force of attraction between them. Okay, we have to calculate the gravitational force of attraction between them. Okay, let us solve this question. So according to universal law of gravitation, we have force equals to G m1 m2 by r square. That is, what is the value of G? 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, leave the units now. Multiplied by mass of first object, that is 9.1 into 10 to the power minus 31, multiplied by mass of second object, that is 1.67 into 10 to the power minus 27, divided by how much? Square of distance between them. What is the distance given? 10 angstrom. Angstrom means it is a unit of measuring length, and that is equal to 10 to the power minus 10 of a meter. Okay, what is 1 angstrom? 1 angstrom is equals to 10 to the power minus 10 meters. Okay, let us solve this question. Take all the numerical values to this side. 6.67 into 9.1 into 1.67, multiplied by all the exponential of 10 to the right side. 10 to the power minus 11 multiplied by 10 to the power minus 31 multiplied by 10 to the power minus 27, divided by how much? It is 10 to the power minus 9 to the whole square. It will be equal to, okay, take this 6.67 as 6.7 and 9.1 as 9. 9 7 is 63, 9 6 is 54 plus 6, 60, and the value will be 60.3. Now 60.3 multiplied by how much? 1.67. Take it as 1.7. 7 3 is 21, 7 6 is 42. Now 603 here because of 1. 603. Now here what will be? 1 3 2 5 2 and 6 4 10, and decimals before 2 digits. So the value is 102.51 multiplied by 10 to the power minus 11 minus 31 minus 27, divided by how much? 10 to the power minus 9 to the how much? 18. That means 102.51 multiplied by 10 to the power 11 plus 31. How much it will be? 42 minus 27. That is minus 69. Minus 69. And take this denominator 10 to the power minus 18 to the numerator. It will become 10 to the power positive 18. So 102.51 multiplied by 10 to the power minus 69 plus 18. How much it will be? Minus 51. We can take it in standard form. 1.02 multiplied by 10 to the power minus 49. Okay, this much Newton of force of attraction is between an electron and a proton kept at a distance of 10 angstrom. Okay, this is the gravitational force of attraction between them. Okay, our next question. Two bodies A and B having masses 20 kg and 40 kg are separated by 10 meters. Okay, there are two masses, that is of 20 kg and 40 kg, and they are kept at a distance of 10 meters from each other. At what distance from body A should another body C of mass 15 kg be placed so that net gravitational force on C is 0? Shall we? So solution for this one, let us take A and B. What is the mass of A? That is 20 kg. Mass of B is 40 kg. And the distance between them is how much? 10 meters. Given in the question, 10 meters of distance. Okay, there is another mass C which has to be kept between A and B. Okay, so we have to keep a object between A and B, that is C. And what is the mass of C? That is 15 kg. Okay, so the question is, at what distance from body A should another body C of mass 15 kg? We have to find out the distance of A to C. This one, X. Okay, the total distance is 10 meters. If we are taking distance from A to C as X, then what is the distance between C to B? It will be 10 minus X meters. No, it will be 10 minus X meters. Okay, for net gravitational force to be 0 on C, okay, the attractive force from B on C, okay, the attractive force, okay, let us take this as B, A and C. The attractive force from B at C should be equal to the attractive force from A on C, okay, but in opposite directions. So we can take it as minus F. So the force between B and C should be equal to the force between A and C, so that they will cancel out each other and the net gravitational force on C will be 0. Okay, let us take the force of gravitation between A and C. That is G mass of A into mass of C divided by how much? What is the distance between A and C? We have taken it as X, square of X. Okay, this will be equal to force of attraction between B and C, that is G into mass of B multiplied by mass of C divided by the distance between B and C, square of distance between B and C, that is 10 minus X to the whole square. Okay, this both should be equal. So let us equate both the equations. We have GMA into MC by X square equals to GMB into MC by 10 minus X whole square. So G will be cancelled out from both the sides and MC will also be cancelled out. Then MA by X square equals to MB by 10 minus X to the whole square. Okay. So what is MA? MA is mass of A, that is 20 divided by X square equals to mass of B is 40 divided by 10 minus X to the whole square. 20 and 40 will cancel out by 20 to the 40. Okay. Now 2x square cross multiplication, 2x square equal to 10 minus x to the power 2. Taking square roots on both sides, what will we get? Taking square roots on both sides, we will have root 2 into x equal to 10 minus x. Then root 2 x plus x equal to 10. What is the value of root 2? That is 1.414. X plus x is equal to 10. Okay. Now taking it here, 1.414 plus 1, that is 2.414. X is equal to 10 and value of x will be 10 divided by 2.414. Okay, on solving we will get approximate value of this one is 2 4 8, again 2 4 2 point. Okay, the approximate value we will get is 4.14 meters. Okay, so the mass C should be kept at the distance of approximate how much? 4.14 meters from A, so that the net gravitational force on C is 0. Okay. Okay, now come to question number 3. Why is the weight of an object on the moon 1/6 its weight on the earth? So we have some given data also. Mass of earth, mass of moon, radius of earth and radius of moon. Okay, so let's start solution. We have to show that the weight of object on earth is 6 times that of weight of the same object on moon, or the weight of object on the moon is 1/6 time the weight of the same object on the surface of earth. Okay, so let the weight of object on earth is equals to g mass of earth into mass of object divided by radius of earth whole square. No, this is the force by which earth attracts that object, and this is called the weight of that object. Okay, so which object? Of mass m. Okay, similarly weight of object on moon will be equal to g mass of moon into mass of that object, same m, and radius of moon whole square. Now take this equation as equation 1 and this equation as equation 2. So dividing this second equation by first equation, we have weight of moon, weight of the object on moon by weight of object on earth equals to g m to mass of object by rm square divided by g mass of earth into mass of object by radius of earth whole square. Again taking this as g m into m by rm square multiplied by re square. It will be reciprocal of the denominator na, g me by into m and g will be cancelled out here. What will be the remaining terms? Mass of moon into radius of earth whole square divided by radius of moon square multiplied by mass of earth. Okay, so let us solve it this side. Okay, so weight of moon divided by weight of earth will be equal to mass of moon, that is 7.36 into 10 to the power 22 multiplied by radius of earth whole square 6.4 into 10 to the power 6 whole square divided by radius of moon whole square 1.74 into 10 to the power 6 whole square multiplied by mass of earth, that is 5.98. Take it as 6 into 10 to the power 24. Okay, on solving we will get this number as 1 by 6. Okay, so weight at the surface of moon divided by weight at the surface of earth will be equal to 1 by 6. That is, weight at moon is equals to 1/6 of weight of the same object on earth. So by this way we can prove that weight of the same object on moon will be equals to 1/6 of the weight of the same object on the surface of earth. Okay, now coming to the next question. Suppose the mass of the earth increases by 20% but the size of the earth remains the same. What will be the weight of the body on the surface of the earth? Okay, suppose the mass of the earth is increasing by 20%. Okay, Suppose mass of the earth earlier was me, and new mass of the earth is me plus mass of earth plus increment of 20%. 20% increment of mass of earth. It will become how much? 6 by 5 times of mass of earth. Now what will be the change in weight of an object if the mass of earth is increasing by 20%? Okay, this is the question. So weight of object, let us take it as the force by which the earth attracts the surface, the earth attracts any object, that is known as your weight. No, so we can also write it as G, mass of earth into mass of object divided by radius of earth whole square. Sorry, radius of earth whole square. Okay, this was the previous weight of object. Now after increasing the mass of earth, we will have weight of object equals to F dash, that is G mass of earth. Okay, after increment it was 6 by 5 into mass of earth into mass of object divided by radius of earth whole square. So we can see that it is increasing by how much times? 6 by 5 times of G me m by re square. Okay, this is same as earlier. No, but it is increasing by how much times? 6 by 5 times. So new weight will be equal to new weight of object will increase by how much times? 6 by 5 times. Okay, that is also equal to 6 divided by 5. It will become 1.2 times. Okay. Okay, let us go to next question. A ball is dropped from the jumping board of swimming pool, which is at a height of 20 meters. A second ball is thrown from the same board after 1 second with initial velocity u. Okay, for the second ball, there is some initial velocity. Okay, for the second ball, there is some initial velocity given to the ball. Both the balls hit the water together. चलिए, बहुत अच्छा क्वेश्चन है ये. एक स्विमिंग पूल है जिसमें वो जो बोर्ड लगा होता है जहां से लोग जंप करते हैं. यहाँ से एक बॉल को जो है कि नीचे की तरफ गिराया गया. ओके, इट इज रिलीज्ड. इसमें कोई भी जो है कि इनिशियल वेलोसिटी नहीं था, तो इसका जो है कि इनिशियल वेलोसिटी कितना हो गया आपका? 0. इसको रिलीज किया गया, छोड़ा गया ऊपर से नीचे. आफ्टर 1 सेकेंड, टाइम जो है 1 सेकेंड पार हो गया. उसके बाद और एक बॉल को ऊपर से नीचे छोड़ा गया, लेकिन इसका कुछ इनिशियल वेलोसिटी दिया गया, उसको कहा गया है u. ओके, इनिशियल वेलोसिटी u दिया गया और ऐसा वेलोसिटी दिया गया कि पहला बॉल जो गया था उसके साथ साथ ये भी जो है कि इस सरफेस पे, वाटर सरफेस पे पहुंच गया. ओके, मीन्स ये जब फर्स्ट बॉल यहाँ पहुंचा था, सेम टू सेम उसी टाइम पे जो है कि सेकेंड बॉल भी यहाँ पहुंचा. So we have to find out this initial velocity that was given to the second ball. ये second ball को कितना initial velocity दिया गया था ताकि वो दोनों बॉल जो है कि एक ही साथ नीचे गिरे. Okay, and the height given is 20 meter. Height of the board is 20 meter. Okay, let us solve it for first ball. Okay, first ball के केस में देखते हैं. Distance was equal to ut plus half at square from the second equation of motion. S is equal to 20 and u was 0, so this term will become 0. Half into a, this is a free falling body, so it will be, let us take it as 10 and t square. It will give you how much time it took to fall to the surface of the water. Okay, 20 into 2 5 is 10, 5 t square. T square equals to 20 by 5. T square is equal to 5 for the 20. T equal to 2 seconds. Okay, the first ball took 2 seconds to fall. 2 seconds. Okay, now the second ball was thrown after 1 second, no? So the time taken by the second ball, okay, time taken by first ball was 2 seconds, and after 1 second the second ball was thrown downwards with some initial velocity. So time taken by second ball was 2 minus 1 seconds. After 1 second it was thrown, so it took 1 second to reach the surface of water. Now let us go for second ball. Distance will be same, s is equal to ut plus half at square. Now we know the time of second ball. Okay, time of travel of second ball, that is 1 second. So we have 20 equals to u. We don't know the value of u, initial velocity given to the second ball, into time. Time was 1 second plus 1 by 2. Again take this acceleration as 10. Okay, 10 multiplied by t square. T square is 1 square. So 20 will be equal to u plus 2 5s are 10, u plus 5. So u will be equal to 20 minus 5, that is u equal to 15 meter per second. Okay, 15 meter per second. So the initial velocity that was given to the second ball was 15 meter per second. Again the question was, what was the initial velocity with which the second ball was thrown? It was your 15 meter per second. Second, do they hit water with same velocity? Okay, let us check out the final velocity of both the balls. Okay, so going with the third equation of motion, v square is equal to u square plus 2as. We know the value of a, we know the value of s, and initial velocity of first ball was 0. So we can have the value of final velocity of first ball, that is u was 0, 2 into 10 into 20 meters. Distance was 20 meters. Okay, so v square equal to 2 10 20, 20 into 20. V is equals to root under 20 into 20, that is 20 square. So v is equals to 20 meter per second. It was for the first ball. Let us take it as v1. Okay, it was for the first ball. The final velocity of first ball is, we found it as 20 meters per second. Now for second ball, v square equal to u square plus 2as. V square we don't know, v square. U square was initial velocity. We have taken we have found the initial velocity as 15, na? 15 square plus 2 into 10 into distance was 20. So 15 square it is 225 plus 2 10 20 into 20, 20 400. It will become 625. That is your v square. Take it as v2. Okay, for second ball. So v2 will be equal to root under 625. 625 is square of 25. So 25 meter per second is the final velocity of second ball. So the question was, do they hit water with same velocity? No. The first velocity, the velocity of first ball was 20 meter per second, and velocity of second ball was 25 meter per second. Okay, let us go for next question. That is, a helicopter is on a mission to drop food for people stranded on a boat. Stranded means फंसा हुआ. Okay, एक हेलीकॉप्टर था जो फूड जो है कि ड्रॉप करने गया था कहाँ, स्ट्रैंडेड बोट पे. इट इज एट अ हाइट ऑफ 20 मीटर and moving with a steady horizontal velocity. Okay, this is about your helicopter. Okay, let us make this figure here. Okay, let us have this helicopter. Okay, we have this helicopter, and it is moving horizontal velocity with the horizontal velocity of 2 meter per second. It is at the height of how much? 20 meters. Okay, now what? When it spots from here, when it spots the nearest end of the boat immediately below it, it drops the packets then. Okay, जैसे ही इसके नीचे वो बोट आता है जिसपे इसको फूड गिरानी है, जैसे ही इसके नीचे आता है वैसे ही वो क्या करता है, यहाँ पे फूड रिलीज करता है। ओके, फूड यहाँ से रिलीज करता है। जैसे ही ये जो है कि बोट के एकदम स्टार्टिंग पॉइंट पे पहुंचता है, वैसे यहाँ से वो क्या करता है, फूड को रिलीज करता है। इफ द लेंथ ऑफ द बोट इज 5 मीटर, लेंथ ऑफ बोट भी दिया हुआ है यहाँ पे आपका कितना, 5 मीटर्स की जो है कि आपकी बोट है। विल द पीपल इन द बोट रिसीव द पैकेट्स? ओके, तो द क्वेश्चन इज, जैसे ही ये हमारा हेलीकॉप्टर जो है, जैसे ही बोट के पास पहुंचता है एट स्टार्टिंग पॉइंट, ओके लुक हियर, एट स्टार्टिंग पॉइंट, जैसे ही बोट के स्टार्टिंग पॉइंट पे ये पहुंचता है, स्टार्टिंग पॉइंट, वैसे यहाँ पे जो है कि फूड को क्या किया गया, ड्रॉप किया गया, नीचे की तरफ ड्रॉप किया गया। लेकिन ड्यू टू इनर्शिया व्हाट विल हैपन, क्योंकि ये जो फूड था राइट साइड में देखिएगा, जो फूड था हेलीकॉप्टर के साथ साथ जो है कि किस वेलोसिटी में चल रहा था आपका, किस वेलोसिटी में, 2 मीटर पर सेकंड के हॉरिजॉन्टल वेलोसिटी में चल रहा था, और उसको जो है कि नीचे भी गिराया गया, मतलब रिलीज किया गया। तो नीचे जो है कि एक्सेलरेशन ड्यू टू ग्रेविटी के कारण, ओके, ग्रेविटेशनल फोर्स के कारण जो है कि वो नीचे जाएगा। अब जो है ये हॉरिजॉन्टल वेलोसिटी भी ट्रेवल कर रहा है और नीचे की तरफ भी जो है कि वर्टिकल वेलोसिटी भी, वर्टिकल डिस्टेंस भी ट्रेवल कर रहा है। अब क्या हुआ, ये इसका जो पाथ होगा वो किस टाइप का होगा हमारा, कुछ इस प्रकार का होगा, है ना, आगे की तरफ भी बढ़ रहा है और नीचे की तरफ भी बढ़ रहा है, इस टाइप का होगा। अब पूछा गया है क्वेश्चन में कि ये जो आगे की तरफ जाकर के गिरेगा तो क्या वो बोट पे गिरेगा या फिर बोट के आगे जाकर के गिरेगा। ओके, लेट अस टेक इट। कब तक ये आगे बढ़ेगा, क्योंकि हॉरिजॉन्टल वेलोसिटी में भी ये जा रहा था, तो कब तक ये फूड पैकेट आगे बढ़ते जाएगा, जब तक वो जमीन पे ना चला जाए तब तक वो आगे बढ़ते जाएगा। ओके, फ्रिक्शन ऑफ एयर जो है कि ये सब हम लोग लेकर के नहीं चलते हैं अभी, तो यहाँ पे जो है कि हम लोग इसको चलिए सॉल्व करते हैं। तो कितना टाइम लगेगा उसको नीचे पहुंचने, पहले ये देखते हैं हम लोग। द डिस्टेंस वाज 20 मीटर्स ना, द डिस्टेंस वाज 20 meters from the boat to the helicopter. So what was the time taken? Let us take the second equation again. S is equal to ut plus half at square. S was 20 meters, ut it was 0, half into a, that is 10, into t square. Here also we will get 20 equals to 5t square, or t will be equal to 20 by 5 root under, it will become root under 4, that will be 2 seconds. So the time taken by this food packet to reach the boat is 2 seconds. Okay, so in 2 seconds it reached the boat. So in the 2 seconds, in that 2 seconds it also traveled the horizontal distance. No, when it was thrown, okay, it was released, it was in motion, it was in motion in the horizontal direction with the speed of 2 meter per second. Okay, so how much horizontal distance it traveled, because we have our boat here, look here, we have our boat here. When the food was dropped, it will go in this direction. No, it will not directly go downwards, because the aeroplane, that helicopter was moving, so due to the inertia the food packet will go like this in parabolic path. Okay, this is your parabolic path. So how much horizontal distance it covered? Let us take it as d equals to horizontal distance, horizontal velocity was constant, so we can use this formula, distance is equal to speed into time. How much time and how much speed was there? Speed was 2 meter per second and time was 2 seconds. So how much distance it covered? 2 into 2, 4 meters. ओके, सो जो हमारा बोट था वो 5 मीटर का था। ओके, और जब जैसे ही बोट के पास पहुंचा था वहां से जो कि खुद को गिराया गया था, लेकिन ड्यू टू हॉरिजॉन्टल वेलोसिटी ऑफ द एरोप्लेन ये थोड़ा आगे जाकर के गिरा, और कहाँ गिरा वो आपके बोट पे ही गिरा, और 4 मीटर के बाद गिरा वो आगे, 4 मीटर के बाद गिरा। तो मीन्स बोट पे जितने भी लोग थे उनको भोजन मिल गया। ओके, नेक्स्ट क्वेश्चन, कैलकुलेट द मास ऑफ अ बॉडी whose volume is 2.4 meter cube and relative density is 0.46. Okay, so we know that relative density is equals to density of substance with respect to density of water at 4 degrees Celsius. No, so density of water, we know what is density of water at 4 degrees Celsius, 1000 kg per meter cube, or in gram per centimeter cube it is 1 gram per centimeter cube. Okay, so relative density is given, it is as 0.46 equals to density of substance by density of water, that is 1000. So density of substance will be equals to 0.46 multiplied by 1000, it is 460 kg per meter cube. Okay, since it is density we have to put the unit of density, 460 kg per meter cube. Okay, now we know the formula of density. Density of substance is equal to mass of substance divided by volume of substance. Because what is density? It is nothing but mass per unit volume. So for the substance we have density of substance as 460, mass of substance divided by volume. What is the volume? 2.4 meter cube. Okay, let's leave the units. So mass of substance will be equal to 460 multiplied by 2.4. So let us multiply 460 2.4. It will become 400, 460 are 24. Okay, 460 are 24, and 4 4 are 16 plus 2 18. 20 0 2 6 are 12, 2 4 are 8 plus 1 9. 0 4 0 11. So here the decimal will be before 0, so the answer will be 1104. Mass of the substance, it will be in kg. Okay, since we are using standard units for everything, so the mass of the substance will come in kg, 1104 kg. Okay, next question, the volume of a 500 gram sealed packet is 350 centimeter cube. Okay, let us write the given points here. Volume of 500 gram. 500 gram is mass of the substance, mass of the packet, no? 500 gram. And volume is how much? 350 centimeter cube. What is the density of packed packet? Will the packet float or sink if the water has density of 1 gram per centimeter cube? Look here, the density is given in gram per centimeter cube, so we don't have to change these units in standard units. We don't have to change it in kg, or we don't have to change it in meter cube. Okay, so what will be the mass of water displaced by this packet? Okay, let us first take out the density of substance. Density of substance is mass per unit volume of substance. Okay, mass of substance was 500 gram and volume was 350 centimeter. 5 tens are 50, 5 7, this one. 10 by 7, it will be equal to around 7 1 is 7, 7 4 is 28. So this around this one, density of that substance is 1.4 gram per centimeter cube. Okay, density of substance. Since density of substance is greater than density of water. Why? Because density of water is how much? It is given as 1 gram per centimeter cube. But the density of substance is greater than density of water, so it will sink in water. Okay, since density is greater, it will be heavier than water. Now, how much the mass of water displaced by this packet? Okay, before finding out the mass of water, we have to find how much volume of water is displaced. How much volume of water displaced by the packet. So the volume of water displaced will be equal to volume of packet. वॉल्यूम ऑफ पैकेट, जितना पैकेट का वॉल्यूम होगा उतना ही वॉल्यूम ऑफ वाटर वो क्या किया होगा, डिस्प्लेस किया होगा. तो वॉल्यूम ऑफ वाटर डिस्प्लेस्ड इज इक्वल टू वॉल्यूम ऑफ पैकेट. हाउ मच इट इज? 350 centimeter cube. And we also know density is equal to mass by volume, and mass will be equal to density into volume. So mass of water we have to find. So density of water multiplied by volume of water displaced. Density of water is given as 1 gram per centimeter cube, and volume of water displaced is 350 centimeter cube. So the mass that is displaced is 350 gram. Okay, the units here was 1 gram per centimeter cube. Centimeter cube will be cancelled out, and 350 gram of mass will come out as the mass of water. Okay, let's go for question number 10. A body floats in oil with 60% of its volume outside the oil. This body floats in water with 40% of its volume outside the water. Calculate the relative density of the oil. Okay, so we have to find the relative density. Okay, let us solve it. जब उस ऑब्जेक्ट को ऑयल में डाला गया तो 60% जो है कि वो ऑयल के बाहर रहा, 60% ऑफ वॉल्यूम जो है कि ऑयल के बाहर रहा, एंड 40% जो है कि इमर्स किया उसको, बट फ्लोट कर रहा था. ओके, नेक्स्ट इन वाटर ऑल्सो 40% जो है कि वो फ्लोट कर रहा था बाहर, और 60% जो है कि वो इमर्स कर गया था अंदर. ओके, सो इन केस ऑफ ऑयल, हाउ मच अपथ्रस्ट वाज देयर? अपथ्रस्ट जो बॉयंट फोर्स लग रहा होगा ऑयल में, तो कितना लग रहा होगा? उस फोर्स के बराबर ऑयल डिस्प्लेस हुआ होगा. द वेट ऑफ ऑयल दैट इज डिस्प्लेस्ड. ओके, दैट वेट इज द फोर्स बाय विच the weight of the object was balanced. No, that's why it was floating on the oil. So oil कितना डिस्प्लेस हुआ होगा? जितना पार्ट ऑफ ऑब्जेक्ट उस ऑयल के अंदर गया होगा. तो हाउ मच पार्ट वाज इनसाइड? 40% ऑफ द वॉल्यूम. let the total volume of that object is V. So 40% ऑफ वॉल्यूम जो है कि वो चला गया. तो इस 40% ऑफ वॉल्यूम का जो वेट होगा, ओके, वेट ऑफ वाटर, वेट ऑफ ऑयल, 40% ऑफ वॉल्यूम ऑफ ऑब्जेक्ट अंदर गया, तो 40% ऑफ वॉल्यूम ऑफ ऑयल को भी जो डिस्प्लेस किया होगा, और इसी ऑयल का जो वेट होगा उतना ही जो कि अपथ्रस्ट लग रहा होगा. ओके, सो सबसे पहले देखते हैं व्हाट इज डेंसिटी. डेंसिटी इज मास पर यूनिट वॉल्यूम. सो mass is equals to how much? Density into what? Density into volume. Okay, so here also upthrust. Okay, अब यहाँ आते, upthrust जो है हमारा कितना लगा होगा? वो जितना भी वॉल्यूम ऑफ ऑयल डिस्प्लेस हुआ, डिस्प्लेस्ड, जितना वॉल्यूम ऑफ ऑयल डिस्प्लेस हुआ उसी का हम लोग वेट निकालेंगे. ओके, इसका हम लोग वेट निकालेंगे. तो इसका वेट हम लोग कैसे निकाल सकते हैं? m इंटू जी. व्हाट इज वेट? वेट इज नथिंग बट mg. सो m हमारा मास हो गया, और मास यहाँ से हम लोग देखते हैं कितना आ रहा है हमारा मास. डेंसिटी ऑफ ऑयल मल्टीप्लाइड बाय वॉल्यूम ऑफ ऑयल डिस्प्लेस्ड, ओके, मल्टीप्लाइड बाय g. इट इज इक्वल टू डेंसिटी ऑफ ऑयल into volume of oil. What is displaced volume of oil? That is 40%. 40 by 100 into V. 40% of V into G. It is equal to rho oil, and this is your 0.4 V into G. This is the upthrust on oil surface. Okay, upthrust on oil surface. इसको एक जगह लिख लेते हैं ऊपर में. अपथ्रस्ट कितना लगा था, जो फोर्स लगा था ये लगा था हमारा डेल्टा ऑयल. डेल्टा मीन्स रो, दिस इज रो नॉट डेल्टा हियर. रो ऑयल multiplied by 0.4 V multiplied by G. Okay, this was the force in oil. Okay, upthrust in oil. Now come in second case, in case of water. Okay. The same upthrust should be there so that the weight of the object will be balanced. No, weight जो है ऑब्जेक्ट का उतना ही ऑब्जेक्ट का अपथ्रस्ट लगना चाहिए पानी में भी, तभी तो उसको जो है कि बैलेंस करके रखेगा, उसको फ्लोट करने देगा. अब पानी के केस में चलते हैं हम लोग. पानी के केस में भी अपथ्रस्ट जो लगा होगा कितना लगा होगा, अपथ्रस्ट इन वाटर इक्वल टू वेट ऑफ वाटर दैट इज डिस्प्लेस्ड. ये ऊपर वाला ऑयल के लिए था, ठीक है. तो वेट कितना डिस्प्लेस हुआ होगा, तो यहाँ पे भी हम लोग देखेंगे वेट क्या हो जाएगा हमारा, mg होता है. यहाँ पे भी m के जगह पे हम लोग क्या लेंगे, डेंसिटी ऑफ वाटर मल्टीप्लाइड बाई वॉल्यूम ऑफ वाटर डिस्प्लेस्ड. ये तो होगा हमारा वेट ऑफ वाटर डिस्प्लेस्ड. तो मास हमारा क्या होगा, डेंसिटी ऑफ वाटर मल्टीप्लाइड बाई वॉल्यूम ऑफ वाटर डिस्प्लेस्ड. कितना वाटर डिस्प्लेस हुआ था, टोटल 60% ऑफ वॉल्यूम जो था वो इमर्स्ड था. 60% ऑफ वॉल्यूम इमर्स्ड था. तो जितना 60% इमर्स रहेगा उतना ही पानी को भी डिस्प्लेस किया होगा. ओके, सो डेंसिटी मल्टीप्लाइड बाई वॉल्यूम मल्टीप्लाइड बाई जी, क्योंकि डेंसिटी और वॉल्यूम मिलकर के क्या हुआ, हमारा मास हुआ. मास क्या है हमारा, यहाँ पे देखिए मास क्या है, डेंसिटी मल्टीप्लाइड बाई वॉल्यूम. तो डेंसिटी ऑफ वाटर मल्टीप्लाइड बाई यहाँ पे ये क्या हो जाएगा, 0.6 आएगा हमारा, 0.6 V इंटू जी. तो डेल्टा रो of water means density of water multiplied by 0.6 of volume multiplied by G. This is the upthrust, and upthrust is nothing but the weight of the object. Okay, since weight of object, जो भी ऑब्जेक्ट था उसका जितना भी वेट था उस वेट को बैलेंस करना हुआ होगा, तभी तो जो है कि वो फ्लोट कर रहा था. फ्लोट करना मतलब क्या हुआ, जितना भी इमर्स किया उस ऑब्जेक्ट के कारण जितना भी वॉल्यूम ऑफ वाटर या फिर वॉल्यूम ऑफ ऑयल जो है कि डिस्प्लेस हुआ होगा, वॉल्यूम ऑफ वाटर या फिर वॉल्यूम ऑफ ऑयल डिस्प्लेस हुआ होगा, उस वॉल्यूम के कारण जो वेट ऑफ वॉल्यूम हुआ होगा उसका वेट जो होगा वो क्या कर रहा होगा, इसको बैलेंस कर रहा होगा. तो अपथ्रस्ट जो है हमारा वो क्या है, वेट ऑफ ऑब्जेक्ट जिसको बैलेंस किया गया था. तो वेट ऑफ ऑब्जेक्ट दोनों केस में तो सेम ही होगा. ओके, दोनों केस में सेम होगा. तो इस दोनों अपथ्रस्ट को हम लोग क्या कर सकते हैं, अपथ्रस्ट दोनों केस में हमेशा सेम रहेगा, क्योंकि उसके वेट को ही हम लोग क्या कर रहे हैं, बैलेंस कर रहे हैं. ऑन सरफेस ऑफ वाटर और सरफेस ऑफ ऑयल उसके वेट को ही बैलेंस किया जा रहा है. दोनों अपथ्रस्ट को हम लोग क्या करेंगे, इक्वल कर देंगे. सो oil multiplied by 0.4 V into G is equal to water multiplied by 0.6 V into G. ये कहाँ से आया, यहाँ से, और ये वाला हमारा कहाँ से आया था, जो पहले निकालते हम लोग यहाँ से. ओके, दोनों अपथ्रस्ट ही था. ये अपथ्रस्ट हमारा कितना आ गया, डेंसिटी ऑफ ऑयल डिवाइडेड बाय डेंसिटी ऑफ वाटर. यही तो हमारा रिलेटिव डेंसिटी था जो निकालना था, इज इक्वल टू 0.6 V इंटू जी डिवाइडेड बाई 0.4 V इंटू जी. जी गया हमारा, V भी चला गया, एंड 6/4. तो डेंसिटी ऑफ ऑयल बाई डेंसिटी ऑफ वाटर इज इक्वल टू 0.6 by 0.4, 2 3 जा 6, 2 2 जा 4, 3/2. So density of oil by density of water is equal to how much? 3/2 or 1.5.